Hi, welcome to clickmeproject.com. Ontologies uses standard machine-readable languages to explicitly define the formal semantics of concepts and their relationships in a domain. Resource description framework for interrogation system will require the domain expert knowledge and data owner authentication, as well as the appropriate ontology prediction for Tamil data ontology-based information retrieval will be complex due to the nature of ontology. So we propose the new mechanism for the ontology framework for geospatial data to supporting the Tamil ontology. For this one, we use the resource description framework ontology for accessing the geospatial data. Our proposed Tamil ontologies is considered the recognition and also considered the similarity the terms in the user given query. Complexity of RDF access, we are applying the triple algorithm for converting the RDF data into the subject-object predicates. This will improve the accuracy of the information retrieval from the both domain experts and the data owners based on flexible query from users. Next, we are going to see the flow of this process. In this process, first we need to collect the data from domain experts. It will creating that ontology search engine. After that collection of ontologies, we have to analyzing the audio files for predicting that major classes. After predicting the classes in that ontology file, next we going to predicting the properties of ontologies. The properties types can having the two ontologies, one for data type properties, another one for object type properties. Classes and subclasses. Classes and subclasses prediction will used to predicting that RDF informations. Then we going to be parsing the dataset and computing the dataset into SQL. After storing the dataset into that server, we getting that user request from client. Next we have to analyzing that request and getting that voice request from the user. In the enable voice option will used to getting that pronunciation and getting that word for community. Then we have to computing that similarity for this process. After computing this similarity, we have to retrieving the results based on the user relevant queries. Next, we are going to see the complete demo of this process. For this one, first we need to run the home.java. After getting this page, we need to load the data set. For this one, I have to choose the ontology dataset, then viewing that file. After this, I have to analyzing the major classes presented in that ontology file. Here we having a 9 classes in this ontology file. After that, I have to computing that overall properties presented in this given ontology file. Next, I am going to be predicted the properties categorization. For this one, I have to computing that what are the data types will be available and what are the object type will be available. For this one, I have to computing that number of data type properties will be 11 and the number of object type properties will be 17. After this, I have to passing the data set into that structure. It will be computing that each class structures and their subclasses. After computing this, we need to pre-processing that each classes. So by using this mechanism, I have to computing that all kind of data pre-processing. After completing this, I have to storing this data into SQL. So this SQL storage will providing the data in the form of table. So now we have to converting that SQL data into RDF files. Next we have to providing that voice input. For this voice input, I have to clicking that recording of voice. In this one, I have to enable the record voice. This will help us to recording their voice into the data. Then I have to stop that recording. After this I have to save the data in form of wave file. Here I have to saving this file as input. After saving this file I have to browsing that file input.wave. It will representing that file path and the size of that bytes having this file and the time of lost modified. Next I have to going to be search the next elements. For this one I have to browse the input files. So now we can able to type that search content in the text area. For that one I have to providing that searching content as from my file. Here I have to typing that word as knack word. Then I have to submitting this document. Now it's recording that file name. So here I have to providing my query as file name. After this I have to click OK, then proceed next. This Java API will calling that voice API to providing your answers. After this completion of the Talking Java SDK, I choose that voice pad option. This will be loading that file which is giving our requested. This is the option for checking that grammar. For this one I have to choosing that file and open text file. For this one I am moving to the Talking Java SDK. For this one I have to choosing any one of files to pronunciate. After computing this processing, I have to stopping that speaking and I move back to that my running frame. Then I have to applying that similarity measures for this query with each attributes. This will providing that computational results. So it will providing that similarity value between that each elements with this query. Here we have to computing the set of elements. From this one we can achieving that optimal novel ontology based information extraction using Tamil ontology. In this one we have to getting that ontology file and extract that information presented in that ontology file. Thank you for watching.